13.2 now. Talking about general angles, and be able to talk about angles in general, and radian measure as a way to measure angles. Okay, so we're going to define an angle very specifically. We're going to define radians as a way to measure angles, degrees being another way to measure angles. We're going to convert back and forth between radians and degrees, and then we're going to find the area and arc length of a sector, the sector being like a piece of pie of a circle. Okay. So to define an angle seems kind of silly maybe, because we have all used angles and kind of know what they are already, but we never really define them very specifically. So it's good you have a general knowledge, and we're just going to define them specifically, how we measure them. Okay. So to measure this angle, you get out your protractor, you put the center right here, and then where would you start? You might start here and measure from here to there. Or you could start from here and measure up to there. That would work too. Okay. These two sides have a name. If, let's say that you didn't measure from there. Let's say you started from here and measured to there. Well, you initiated your measurement at this side. So this is called your initial side. Okay, and you terminated your measurement here. You ended the measurement here, so this is called the terminal side. Okay, so those are just two words, two terms that we use when we talk about measuring angles. Okay, so we're now going to kind of agree. If I tell you 30 degrees, what does that mean? Does that mean starting here and measuring here, here, and there? Or is it like some angle that's off in this direction, and you start here and measure to that side? We're going to agree to measure in the same exact way so that everybody understands. If I'm talking to you on the phone in Germany, you know what I mean by 30 degrees. Okay, so let's start out here on the XY axis, these axes, X and Y. Okay, so we're going to agree that if we're going to talk about a standard angle, an angle in standard position, that means that our initial side, where we start to measure, is always going to be right here, always, always. Okay, so I tell you an angle is in standard position, that means you start measuring here, and wherever you measure from here, that's how far away you measure to. That's how you determine where your angle is. Okay, so if I measured from here and I wanted to measure out 120 degrees, I'd start here and then end over right about here. That'd be 120 degrees. Okay. Well, that would be, we're all going to agree then, that's the positive direction. And if there's a positive, there's a negative, so this is the negative direction. This is positive, negative. So as long as they keep going around like this, this is positive. As long as they keep going around like this is negative. And you can measure as big an angle you want. You can measure 180, 360. You can measure around again from 360 another 180 and get to 540. And keep going and going and get thousands and millions and billions of degrees if you want. Okay? And we'll talk about how to indicate that like in a drawing. Okay? So that's the important part, that on the positive x-axis, that is your initial side. Initial side. And that this direction, starting up and going around this way, like counterclockwise, that's positive. Clockwise is negative. Okay, you'll get used to that after a while. All right, so positive, negative, initial side, that's pretty much it. All right, and we'll do some examples of that later on. But moving on to radians. Now, don't let radians throw you off and make you feel queasy or anything. Radians are just a different way to measure angles. So we can measure lots of different things in lots of different ways. It just depends on what we're measuring. We can measure distances in miles or kilometers, feet. We can measure it in yards or meters or whatever we want to measure it in. That's all. They're all ways to measure distance. Okay, and we can convert between them. Volumes. You can measure things in gallons and liters, in cubic centimeters, in cubic yards, cubic feet. all these things are measurements of volume. Okay, so in the same way, angles have different ways of measuring. And I'm going to give you a simplistic, straightforward, not really a definition, but a way to understand radians. Okay, so let's imagine a circle here, because we know that it's a bad circle. In a circle, there's 360 degrees. You start here, you measure all the way around the circle, that's 360 degrees. Okay, so let's just go halfway around. Halfway around in degrees is 180 degrees. Now, this thing called radians, we can measure in radians also. And to measure halfway around the circle in radians, that's pi radians. Okay. Now, you might be able to imagine that, say, in like formulas for, say, circumference and area and all these kinds of things, pi would probably be a pretty natural fit into those equations. So, that's part of the convenience of using radians. So if from here all the way around, well, I guess halfway around the circle, but all the way over to here, that's an entire 1 pi. Well, what if I come this far? Well, straight up and down, that's halfway to 180. That's 90 degrees. That's halfway to 180. Well, if it's halfway to 180 and pi is just as much of an angle as 180, then this must be halfway to pi, or pi divided by 2. Okay. And if I go halfway to 90 I know in degrees is 45. Well, if this is halfway to 90, this must also be halfway to pi over 2. Well, halfway to pi over 2 would be pi over 4. Divide 1/2 in half and you have 1/4. Okay, how about this one? This one's another common one. This one we'll say is 30 degrees. Well, think about 30 degrees. You need 6 of those, right? I'd go 30 degrees, another 30, another 30, 30, 30, 30. You use 6 of them to get to 180. So if I'd use 6 30 degrees to get to 180, I must use 6 of, however many radians this is to get all the way to pi radians. Okay, so imagine I use 6 of these things, and 6 of these things adds up to pi. Well, then that must be a 1/6 of a pi must be the thing that I use 6 of to get all the way around. Okay, this thing in radians is the same fraction of pi as 30 is of 180. Divide 180 by 30, you get 6. Divide pi by pi over 6, you get 6. Multiply 30 by 6, you get 180. Multiply pi over 6 by 6, you get pi. Hopefully you get the idea. Now look at this one. This one's 60. And how many 60s are in 180? There's 3 of them. So there must be 3 of these measurements in radians to get to pi. So this is pi over 3. Okay. Well, let's come over here. This one's 120. 120 is 2 60s. 60 plus 60 is 120. So it must be 2 times this thing. Must be however many radians this is. 2 times pi over 3 would be 2 pi over 3. How about this one? This is some pi over 4 measurement, right? This is like some multiple of 45. Well, it's 1, 2, 3 times 45, so it must be 3 times pi over 4, and it is. It's 3 pi over 4. And this is 135 in degrees. And the last one we're going to throw in here, well, this is just 30 degrees away from 180, right? It's 150. Well, it's 30 degrees away from 180. It's one of those 1/6 away from 180, so it must be also one of these guys away from 180, or away from pi. So we come all the way in these little 30-degree chunks, these little pi over 6 chunks, and we would need one more to get to pi, and an entire pi would be 6 of those. So this would be 6 pi over 6, so this must be 5 pi over 6. And this is 150 degrees. Okay. So, we will talk about converting from degrees to radians and vice versa in the sample problems videos. Okay. But part of the usefulness of the radian is that it's just so easy to put into formulas rather than using degrees. If you use degrees, these formulas that I'm about to show you would be more complicated. So let's say we're looking at a circle, and right from the center, just like you cut out a piece of pie, we look at a piece of this circle, and this piece has an area, and also if you measure along the curve of it, what we call an arc. An arc is the name of a curve that's a piece of a circle. Okay. This is a curve as well, but it's obviously not a piece of a circle. It's too like squished or stretched, whichever way you look at it, to be part of a circle. So anyway, arc is the name of a curve that's a piece of a circle. So this arc is a certain length, and this little piece here is a certain area. Now we know that the area of a circle depends on its radius. So in the same way, the area of this sector will depend on the radius, and it'll also depend on how big of an angle is it. Okay, so these formulas will involve the radius and the angle. So arc length, this is actually represented by the lowercase s, kind of a weird pick. I would have picked L, but that's what it is. And the arc length is equal to the radius times the angle. Now this is where it's important. Think about the radius. Okay, that's straightforward. It's whatever is said there. But for the angle, think about if this radius was 5 and this angle was 15 degrees. Okay, so you do 5 times 15. But then somebody else says, well, I know about radians, and I'm going to use radians. That's pi over 12 is 15 degrees, so I'm going to use that. Those two people are going to get two different numbers. They're going to get two different answers. So it must make a difference whether you use degrees or radians. And, just so we're clear, you should be using radians in this formula and in the area formula. For the area is equal to 1/2 r squared times theta, the angle. And again, theta should be measured in radians. Alright, so pretty simple formulas. Make sure you use radians in both of these, and we'll see that in the example problems.